Welcome back students. In this video we are going to give a detailed introduction to complex numbers, what is iota and powers of iota, algebra of complex numbers, conjugate, modulus and argument of complex numbers with properties, what is Argand plane, representation of complex number in different forms, De Moivre's theorem, cube roots of unity, locus problem, rotation, geometry in complex number, result related with the triangle, then equation of line through the points Z1 and Z2 and equation of a circle. Now in this Venn diagram we see that the set of all natural numbers, what is the natural numbers? Numbers from 1, 2, 3 etc. infinite set is contained in the set of all whole numbers. Whole numbers are numbers from 0, 1, 2, 3 etc. is contained in the set of all integers. Integers from all the negative numbers 0 and all the positive numbers, and it is again contained in the set of all rational numbers. Rational numbers minus 0.025, for example, it is given in the diagram, minus 5/8 and so on, which is again contained in the set of all real numbers. Real numbers contains the sets of natural number, whole number, integers, rational numbers, irrational numbers. Irrational numbers, root of 10 pi comes under irrational number, and the set of all the numbers along with the imaginary numbers comes under the set of complex numbers. So natural numbers is contained in the set of whole numbers, contained in the set of integers, which is again a subset of all the rational numbers, subset of all the real numbers, again subset of all the complex numbers. So 0 is both purely real as well as purely imaginary, but not imaginary. What is this imaginary? Let us see. Here, for example, we take a equation x square plus 16 is equal to 0. Now this x square is equal to minus 16 and x will be is equal to root of minus 16, which is equal to root of minus 1 into root of 16, where x is equal to root of minus 1. This root of minus 1 is taken to be iota I, and root of 16 is plus or minus 4. This root of minus 1 is taken as iota. Iota is, the value for iota is root of minus 1. So when I say imaginary number is I. Any number in the complex form can be represented as a plus ib, where we have a is equal to any complex number can be represented as z is equal to a plus ib, where we say that this a is the real part of z and the number which is accompanied with this iota is called as the imaginary part of z. So this z is equal to a plus ib is a complex number consisting of both the real and the imaginary part. Every complex number can be regarded as, when we take a complex number, for example, some z is equal to a plus ib, then this complex number can be regarded as, this is equal to, it is said to be purely real. The complex number is said to be purely real if the imaginary part is 0. This number is 0, and it is said real part is equal to 0 and the imaginary part is not equal to 0. Next, moving on to integral powers of iota. Iota, we know iota is equal to root of minus 1. Therefore, squaring iota square will be is equal to minus 1. Iota cube will be is equal to iota square into iota, which is equal to minus I. And iota power 4 is equal to I square into I square, which is equal to minus 1 into minus 1, which is equal to 1. So iota power 4 is equal to 1 is very important. Now we have seen in this introduction, for example, this is not always true. For example, I take a is equal to some number which is equal to minus 8. We'll check whether this is possible and this is true. A is equal to minus 8 and b is equal to minus 32. Let us check for root of a into root of b. What is root of a? Root of b, which will be is equal to root of minus minus 8 into root of, I take the number as 32 here, minus 32. Now this is equal to root of minus 1 is I, so root 8 into I, root of 32, which can be written as I into root of 2 cubed into I into root of 2 power 5. This I and I is I square minus 1, so minus root of 2 power 3 into 2 power 5, which is equal to minus root of 2 power 8, which is equal to minus 2 power 4, which is equal to minus 16. Now I get the left hand side to be minus 16. Let us check for the right hand side. Right hand side is root of AB, which is equal to root of minus 8 into minus 32. Minus into minus becomes plus, and this is 2 cube into 2 power 5, which is equal to root of 2 power 8, which is equal to 2 power 4, which is equal to 16. Now we see that this root of AB is not equal to root of A into root of B, and this is possible. Root of A into root of B is equal to root of AB is possible only if at least one is non-negative. Only if at least one is non-negative. I power minus m, where m belongs to the set of all natural numbers, rewrite this number I power minus m by using its reciprocal 1 by I power m, and we have to ensure that there is no I in the denominator. Let us check for an example here. Now for example, I want to find the value of I power 2024. This I power 2024 will be is equal to I power 4 the whole power 506. I power 4 we know is equal to 1 whole power 506, which is equal to 1. Now I want to finalize that I power 4n plus I power 4n plus 1 plus I power 4n plus 2 plus I power 4n plus 3. Let us see what is the value for this. Now this is equal to I power 4n we know is equal to 1. I power 4 is 1, so I power 4n is 1. This value is I power 4n is 1 into I squared becomes minus 1, so this is minus 1. I power 3 becomes minus I, so this is minus I. Now this gives us 0. For example, let us take the values of I power 1 plus I power 2 plus I power 3 plus goes on up to I power 12. Now let us see what is the value for this. This is equal to I power 1 plus I power 2 plus I power 3 plus I power 4. Sum of all the numbers, we know consecutive numbers we get here. I power 5, I power 6, I power 7 plus I power 8. Next set I power 9 plus I power 10 plus I power 11 and I power 12. Now this sum of consecutive numbers, I is for I, this is I minus 1, again I cube is minus I plus I power 4 is 1, which gives us 0. Now this is sum of the consecutive numbers 0, sum of the consecutive numbers is 0, and therefore the sum of all the numbers sigma I power n, where I is equal to 1 to 12, can be taken to be is equal to 0 here. Now let us see this question. What is the value of I square I power 4 plus I power 6 plus I power 8 up to I power 2n, where n is even? Now this can be grouped as I square plus I power 4 plus I power 6 plus I power 8 plus goes on up to the last term will be I power 2n minus 2 plus I power 2n. Now the value for this I square we know is minus 1, I power 4 is plus 1. Plus I power 6 can be written as I power 4 into I squared. I power 4 is 1, I square is minus 1, so gives us again minus 1. I power 8 is a multiple of 4, so this is plus 1. Plus goes on up to this is again minus 1 plus 1. Now the value will be is equal to 0. 0 plus 0 plus 0 plus goes on, which is equal to 0. The next important question, the value of sigma n is equal to 1 to 13, I power n plus I power n plus 1 is. So 4 options are given. Here we know that the sum of 4 consecutive powers of I will be is equal to 0. Using this we are going to do the sum here. So this can be split further as sigma n is equal to 1 to 13 I power n plus sigma n is equal to 1 to 13 I power n plus 1. So sum of 13 terms here. So let me take I outside. I plus sigma n is equal to first term is taken. So it will be n is equal to 2 to 13 I power n plus I take n plus 1 is given here. So taking I square sigma n is equal to 2 to 13 I power n plus 1. Now this gives us, this is equal to I plus, so this gives us I into sigma n is equal to 2 to 13. This is actually summation of all the numbers I squared plus I cube I power 4 goes on up to I power 12. This is I square plus I cube plus goes on plus I power 12. I power 13. So total number of terms 12 terms. So sum of consecutive powers of I value is 0 plus I square. Similarly, this will be is equal to the second term. I square is taken out. So I square plus the next term will be I power 3 plus I power 4 plus I power 5 goes on plus I power 13 plus 1 will be 14, 12 terms here. So similarly, the sum of the consecutive terms is 0. So I square plus we get 0. This is equal to I plus I square, which is equal to I minus 1. So our answer is I minus 1. Now a small recap of what we have learned. Real number systems couldn't solve the equations such as x square plus 1 equal to 0. So highlighting a gap, we found what is I. X square plus 1 is equal to 0, or x square is equal to minus 1, x is equal to plus or minus I. Now the imaginary unit I is equal to root of minus 1 was introduced, and the property I square is equal to 1 made previously unsolvable equations solvable, greatly expanding the mathematics. Complex number Z is equal to A plus IB consists of the real part A and imaginary part B. Fundamental operations, we see what are the algebraical operations on addition, subtraction, multiplication and division. Now consistently applying that I square is equal to 1. First let us see addition of two complex numbers. Two complex numbers addition, for example, let me take Z1 is equal to 1 plus 2i and another complex number Z2 is equal to 3 minus 4i. Now let me add these two complex numbers. Z1 plus Z2 will be is equal to 1 plus 2i plus 3 minus 4i. Now when we add the real parts together. This gives me is equal to 1 plus 3 plus I into both the imaginary parts, which is equal to 2 minus 4. Now this is equal to 4 minus 2i. This is how we add the complex numbers. Same with the same example, let us subtract the complex numbers. Z1 minus Z2 gives me is equal to 1 plus 2i minus 3 minus 4i. Now this is equal to 1 plus 2i minus 3 plus 4i, which is equal to, adding the real numbers, 1 and minus 3 gives me minus 2 and 2 and 4 gives me plus 6i. So Z1 minus Z2 will be is equal to minus 2 plus 6i. Multiplying the two complex numbers, for example, let us take the same question. Here Z1 is equal to 1 plus 2i and Z2 is equal to 3 minus 4i. Now multiplying Z1 into Z2 will be is equal to 1 plus 2i into 3 minus 4i, which gives me is equal to, multiply the numbers, 1 into 3 gives me 3, multiply both the real parts, multiplying both the imaginary parts gives me the real part. So that is plus I square is minus 1, 2i into minus 4i gives me I square is minus 1 into 2 into minus 4 gives me minus 8. So this gives me plus 8, the real part, plus I into, now multiplying the imaginary parts, I into 2i into 3 gives me is equal to 6, and the next number will be minus 4. This gives me is equal to 11 plus 2i. When we want to divide two complex numbers Z1 by Z2, which is equal to 1 plus 2i divided by 3 minus 4i multiplied by the conjugate of the denominator. So this gives me, multiply with 3 plus 4i, divided by 3 plus 4i. Now this is equal to, multiplying 1 into 3 gives me 3, 2i into 4i, which is equal to plus 8i plus 16, which is equal to minus 5 plus 2i divided by 25. Now separating the real and imaginary part, it can be written as minus 5 by 25 plus 2i divided by 25. Next, inverse, multiplicative inverse of a complex number is denoted by Z inverse. Suppose let me take Z is equal to x plus iy. Then Z inverse will be is equal to 1 by x plus iy multiplied by the conjugate of the denominator. We get that is x minus iy divided by x minus iy, which is equal to x minus iy divided by x square minus I square y square, which gives us plus y square, and the real part will be x by x square plus y square, and the imaginary part will be plus I into minus y divided by x square plus y square. Complex numbers obey the laws of indices. That is, z power m into z power n can be written as is equal to z power m plus n, and z power m by z power n can be written as is equal to z power m minus n, and z power m whole power n can be written as z power mn. The next one, z power 1, z1, z2, two complex numbers, product of two complex numbers, whole power m can be written as z1 power m into z2 power m. Conjugate, modulus and the Argand plane. Conjugate z bar. So if z is equal to x plus iy, then its conjugate is given by, if z is equal to x plus iy, its conjugate z bar can be written as is equal to x minus iy. So changing the sign of the imaginary part, if plus is given, we give it as minus, then that is the conjugate of the given z. Now coming to the properties of the conjugate, the properties of conjugate. If f is a polynomial with real coefficient, then f of alpha plus I beta is equal to x plus iy. Then f of alpha minus I beta is equal to x minus iy. These are the properties of conjugate. Next, what is this modulus of a complex number? The distance from the origin to z in the Argand plane, modulus of z is equal to root of a square plus b square, represents the magnitude. First, let us see what is this Argand plane. Argand plane in 2D coordinate system, where the x-axis is the real axis and the y-axis is the imaginary axis. Z is equal to a plus ib is represented by the point a comma b. Now this is the Argand diagram. This x-axis will be called as the real axis and the y-axis is called as the imaginary axis, and this line passing through the origin, this is the origin, and the line from the origin to any point. For example, I take the point here as the complex number z, where z is equal to x plus iy can be written in terms of coordinates x comma y. The distance from the origin to any point taken to be is equal to some x. This distance is equal to x, and the distance from the x-axis to the z will be taken as y. Then this line 0 to z, O to z will be the modulus of z. Modulus of z will be is equal to root of a square plus b square as given in the definition, that a and b, if the points here I have represented as x and y, therefore it will be root of x square plus y square. If z is equal to a plus ib, then modulus of z will be is equal to root of the real part square a square plus b square. So in the distance from the origin to z, the given point will give us the modulus of z. Now coming to the properties of modulus. Properties of modulus of a complex number. Let us take z is equal to some a plus ib, be a complex number. The first property is modulus of z is equal to modulus of z bar. then that is modulus of x plus iy, a plus ib is equal to triangle inequality whole modulus of z1 minus modulus of z2 is less than or equal to modulus of z1 plus z2 less than or equal to modulus of z1 plus modulus of z2. This is called as triangle inequality. Similarly, modulus of z1 whole modulus of z1 minus modulus of z2 is less than or equal to modulus of z1 minus z2 less than or equal to modulus of z1 plus modulus of z2. Let us see an example. If modulus of z is equal to 2, show that 3 is less than or equal to modulus of z plus 3 plus 4i less than or equal to 7. Let us take this z as is equal to z1 complex number and 3 plus 4i is another complex number. Using this property here, we are going to write this is whole modulus of z1 minus modulus of z2 is 3 plus 4i is less than or equal to modulus of z plus, I write the given question here, is z plus 3 plus 4 iota is less than or equal to modulus of z plus modulus of 3 plus 4 iota here. Now this gives us modulus of z is equal to 2, so 2 minus modulus of 3 plus 4i. So how to find the modulus? This is equal to root of 3 square plus 4 square, which is equal to root of 9 plus 16 root of 25 is equal to 5. Now root of 25 which is equal to 5. So this is 2 minus 5 less than or equal to modulus of z plus 3 plus 4i, which is less than or equal to modulus of z is 2 plus modulus of 3 plus 4 iota is plus 5. So we get this is equal to modulus of 2 minus 5 is 3 less than or equal to modulus of z plus 3 plus 4 iota less than or equal to 7. Hence proved. We have seen the Argand plane. In this Argand plane, we know that the real axis will be the x-axis and the y-axis will be the imaginary axis. If z is a point representing the real and imaginary values as x plus iy, that is z is equal to x plus iy, from the origin, the distance from the origin to z is given by modulus of z, which is equal to root of x square plus y square. This angle theta from the positive side of the x-axis is called as the argument or amplitude. The value of this theta will be is equal to, theta is equal to tan inverse of y by x. The value of theta will be tan inverse of y by x if z is equal to x plus iy and for z is not equal to 0. The principal value of argument of z is said to be unique and it satisfies that argument of z is less than or equal to pi. That is, theta belongs to open interval minus pi comma pi closed interval. Next, maximum and minimum of modulus of z. If modulus of z plus 1 by z is equal to a, where a is greater than 0 positive, then the maximum of z, maximum of modulus of z is given by a plus root of a square plus 4 divided by 2, or this is equal to 1 by 2 into root of a square plus 4 plus a, and the minimum of modulus of z is given by is equal to 1 by 2 into root of a square plus 4 minus a. Let us see a question here. If z belongs to the set of complex numbers, if the minimum value of modulus of z minus 3 root 2 plus modulus of z minus p root 2i is 5 root 2, then value of p is we have to find. So we know the distance between two complex numbers. Two points, that is z1 and z2, is given by modulus of z1 minus z2. Distance between two complex numbers is given by z1 minus z2. So here the distance between the point and another point, the point is taken to be is equal to, the imaginary part is 0. So the point will be 3 root 2 comma 0. This is one point, and the next point here, this is the distance between the point some z2 and the point, and the other number will be, the real part is 0, and therefore 0 comma of the two distances become minimum. The point cannot be represented here. Let us consider the point lies on the line segment AB here. This is A and B. Point lies on the line segment AB to be minimum. Then the distance of PA and PB will be minimum. That is AP plus PB. The minimum distance between AP and PB will be the given point P, which lies on the line segment AB. Therefore, since it lies on the line segment, therefore, using the distance formula, the distances from the given two points, that is 3 root 2 the whole square plus P root 2 the whole square is equal to 5 root 2. This gives us 18 plus P 2P square. This gives us 18 plus 2P square is equal to 25 into 2, which is equal to 50. Or 2p squared will be is equal to, or which p square is equal to 16, which implies p is equal to plus or minus 4, and p cannot be minus 4, and so we take p is equal to 4 from the option. Modulus properties, we have seen the modulus properties. Next, coming to the argument properties. Argument implies the theta value, positive direction from the x-axis. So argument of product z1 z2 is equal to argument of z1 plus argument of z2 plus 2k pi. Argument of z1 by z2 is equal to argument of z1 minus argument of z2 plus 2k pi. This is an important property. Triangle inequality. We have seen the triangle inequality, finding the maximum and minimum values in the problem. Next, moving on to the representation already. What is this rectangular form? There is a complex number z is equal to some x plus iy is the form called as a Cartesian form or rectangular form. And the next one is the polar form of a complex number and the Euler's formula. This polar form of a complex number is nothing but in the form of r comma theta. The complex number is represented as r into cos theta plus I sin theta. The short form of this can be written as r into cis theta. Now this r represents the modulus value of the complex number, modulus of z, and theta represents the argument value or the amplitude, argument or amplitude of z, where theta is equal to argument of z. If z is equal to 0, the argument theta is undefined, and so it is understood that if z is not equal to 0, whenever the polar coordinates are used, if z is equal to x plus iy, the polar coordinates are given as r comma theta, and z is equal to x minus iy, polar coordinates are r comma minus theta, where r is equal to the modulus value, that is root of x square plus y square, that is modulus of z, and r theta will be is equal to tan inverse of y by x. And we know that minus pi is less than argument of z less than or equal to pi. Now let us see the principal argument of a complex number. In the first quadrant, the values will be theta is equal to alpha. This theta is equal from the origin. We take a complex number z, making an angle alpha with the x-axis. Then this first quadrant, theta will be is equal to alpha. Suppose this z lies in the second quadrant and the angle made by it will be is equal to some alpha. Then the argument theta, this theta with the positive side of the x-axis, theta will be is equal to pi minus alpha. So second quadrant it is pi minus alpha. Third quadrant it is theta is equal to alpha minus pi, and the fourth quadrant theta will be is equal to minus alpha. Let us see an example for this. It is very important that theta is equal to alpha in the first quadrant, theta is equal to pi minus alpha second quadrant, theta is equal to alpha minus pi in the third quadrant, and theta is equal to minus alpha in the fourth quadrant. Let us take the question. Find the modulus and principal argument of root 3 plus I. Its modulus value r is equal to whole root of root 3. We know that r is equal to x square plus y square, which is equal to whole root of root 3 the whole square plus 1 square, which is equal to root of 4, which is equal to 2. And alpha will be is equal to tan inverse of modulus of y by x, the imaginary part by real part, which is equal to tan inverse of 1 by root 3, which is equal to pi by 6. So here in the Argand diagram, theta will be is equal to, here modulus r is equal to 2 and theta will be is equal to pi by 6. Considering the problem, the second question, minus root 3 plus I, r is equal to root of root 3 whole square is 3 plus 1, which is equal to 2. Now here x is negative and y is positive. X is negative, y is positive, so the theta lies in the second quadrant. Second quadrant we know is equal to pi minus of alpha. So here, what is this alpha here? Alpha will be is equal to tan inverse of modulus of y by x, which is equal to 1 by minus root 3. But it lies in the second quadrant, therefore it must be taken as pi minus of pi by 6, which is equal to 5 pi by 6. Considering the question, minus root 3 minus I lies in the third quadrant. In the third quadrant, and this will be is equal to theta. Now third quadrant we know. Considering the next problem, here the root 3 positive and minus 1 is negative, therefore theta lies in the fourth quadrant from the origin, and therefore theta can be taken as theta is equal to minus alpha. So when we want to find the modulus, that is equal to root of root 3 the whole square plus 1 square, which is equal to root of 4, which is equal to 2, and the argument value of theta will be is equal to minus of alpha, which is equal to minus pi by 6. Now let us see how to represent a given number in polar form. Representation of given number, for example, we take the number as 1 plus I root 3, write it in polar form. This is in Cartesian form or rectangular form. We have to write it in polar form. So 1 plus I root 3 can be written as its modulus value is 2 and theta is equal to argument value is tan inverse of root 3, which is equal to pi by 3. So r into cos of pi by 3 plus I sin of pi by 3, and the general form it must be written as 2 into cos of pi by 3 plus 2k pi plus I sin of pi by 3 plus 2k pi, where k belongs to z. Next problem, find the principal argument when z is equal to minus 2 by I root 3. We are going to use the property argument of z1 by z2 is equal to argument of z1 minus argument of z2. So here argument of z can be written as is equal to argument of minus 2 minus argument of 1 plus I root 3. This minus 2 lies in the second quadrant, and therefore second quadrant we know the principal value is pi minus of alpha, and therefore argument of a real value. So this is pi minus of tan inverse of imaginary part is 0 divided by the real part is 2 minus argument of I root 3 will be tan inverse of root 3 by 1. Now this is equal to pi tan inverse of 0 is 0. So we get pi minus tan inverse of root 3 is pi by 3. So pi minus pi by 3 will be is equal to 2 pi by 3. This implies that one of the values of argument of z is 2 pi by 3. This 2 pi by 3 belongs to the interval minus pi comma pi. If z is equal to r into cos theta plus I sin theta, then the Euler's form of the complex number is given by r into e power I theta. If theta is e power minus theta, I theta will be, where e power minus I theta will be is equal to 1 by e power I theta, and this e power I theta whole conjugate will be is equal to e power minus I theta. And the two complex numbers, if there are two complex numbers where z1 is equal to r1 e power I theta 1 and z2 is equal to r2 into e power I theta 2, then these two complex numbers are said to be equal only if z1 and z2 are equal, only if r1 and r2 are equal, and theta 1 will be is equal to theta 2 plus 2 n pi, where n belongs to z. To find the argument here, minus 4 lemma of 4 lies in the second quadrant. Therefore, theta will be is equal to second quadrant. We know theta is equal to pi minus alpha in the second quadrant. Therefore, angle will be pi minus 4 by 4 is equal to 1. Tan inverse of 1 is pi by 4. So now this is equal to argument of z will be is equal to 3 pi by 4. Next question, z is equal to minus 1 minus I. Minus 1 minus I. X is negative, y is also negative. So minus 1 lies in the third quadrant. In the third quadrant, we know theta is equal to minus alpha minus pi. So alpha minus pi, alpha is 1 by 1. Tan inverse of 1 is pi by 4 minus pi, which is equal to, so here argument of z will be is equal to minus 3 pi by 4. Z is equal to 5. Z is equal to 5 is a point on the x-axis. So here theta will be is equal to 0. So in this case, argument of z will be is equal to 0. Z is equal to minus 5. If z is equal to minus 5, then minus 5 lies on the negative side of the x-axis. Therefore, z will be is equal to pi. The next question, z is equal to 7i. 7i. So point lies on the imaginary axis 7i. So what will be the angle here? Angle will be is equal to pi by 2. So we say argument of z will be is equal to plus pi by 2. So in general we can say argument of the real number will be is equal to 0 if a is greater than 0 and is equal to pi if the number is a negative number. Argument of an imaginary number ai is equal to pi by 2 if a is greater than 0 and is equal to minus pi by 2 if a is less than 0. Next question, let z is equal to 1 plus I and z1 is given, z is equal to 1 by 1 plus I multiplied by the conjugate 1 minus I by 1 minus I, we get is equal to 1 minus I divided by 2. So this is 1 minus I divided by 2. Now this gives us this is equal to 2 plus I square is minus 1, so gives us 2 plus I divided by minus 1 minus I plus 1 minus I divided by 2. Now this again is equal to 2 into 2 plus I, taking the LCM here, divided by, we get multiplying by 2 minus 2i plus 1 minus I. Now again this gives us, this is equal to 2 into 2 plus I divided by minus 2 plus 1 is minus 1 minus 3i. Multiplying by the conjugate of the given plus I. This is the value for our given question is Z1. Now our question is find the then 12 by pi into argument of Z1. Now the point 1 comma minus 1 comma 1 lies in the second quadrant and by 4. So that is theta is equal to 3 pi by 4. Therefore, that is argument of Z1 is 3 pi by 4. Now the question is 12 by pi argument of Z1. So 12 by pi into argument of Z1 will be is equal to 12 by pi into 3 pi by 4. Now this gives us 9. So answer is 9. Let us recall what we have learned. Polar form of a complex number z is equal to r into cos theta plus I sin theta. R is equal to modulus of z, which is equal to root of x square plus y square if z is equal to x plus iy, and theta is the argument angle with the positive real axis. Principal argument lies in open interval minus pi comma pi, closed interval, or in the interval 0 comma 2 pi. This provides a unique representation. R into e power I theta is a Euler form of a complex number, and the Euler's formula is given by e power I theta is equal to cos theta plus I sin theta, and we have learned how to convert from Cartesian to polar form or the Euler's form. If n is a positive integer, then find the value of 1 plus sin theta plus I cos theta plus I divided by 1 plus sin theta minus I cos theta. Let's take z is equal to some sin theta plus I cos theta. Therefore 1 by z will be is equal to sin theta minus I cos theta. Therefore our question can be written as, in De Moivre's theorem, it can be written as cos n pi by 2 minus theta plus I sin n pi by 2 minus theta. To find the nth root of your complex number, the number omega is called the nth root of a complex number if omega power n is equal to z, or omega is equal to z power 1 by n. Working rule to find the nth root of your complex number: first write the number in polar form, add 2 k pi to the argument value, apply the De Moivre's theorem, that is bringing the power inside, and put k is equal to 0, 1, 2, etc. up to n minus 1. To find the cube roots of unity, let us take z is equal to 1 whole power 1 by 3, where n is equal to 3 here. So writing the number 1 in polar form, 1 can be written as cos 0 plus I sin 0. So 0 plus 2k pi plus I sin 0 plus 2k pi whole to the power of 1 by 3. So rewrite the number in polar form we have written. Now this can be written as, apply the De Moivre's theorem, so this can be written as cos 2k pi by 3 plus I sin 2k pi by 3. Now giving the values for, or this is equal to e power I 2k pi by 3, writing it in Euler form. Now this is equal to, applying the values for k is equal to 0, 1 and 2 up to n minus 1. So n is 3 here, we give k is equal to 0, 1, 2. Next equal to cis 2 pi by 3, which gives us the value which is equal to minus 1 by 2 plus I root 3 by 2. When k is equal to 2, z gives us z is equal to cis 4 k pi by 3. That is cis 4 pi by 3, which can again be written as cis pi plus pi by 3, which is equal to minus cos pi by 3 minus I of unity r. The roots of unity are 1, minus 1 by 2 plus I root 3 by 2 and minus 1 by 2 minus I root 3 by 2. Now let us take these values as 1, omega and omega square, where omega is equal to minus 1 by 2 plus I root 3 by 2. Now plotting these points on the unit circle, where this value is 1, the point, this will be minus 1 by 2 plus I root 3 by 2. And the next point, x is negative, y is also negative, so the value lies in the third quadrant. We get, plotting the points on the unit circle, we get an equilateral triangle. Now we can note that if omega is equal to minus 1 by 2 plus I root 3 by 2, then omega square will be is equal to minus 1 by 2 minus I root 3 by 2. Taking the sum of the roots 1 plus omega square, we get this is equal to 1. This is equal to minus 1 by 2 plus I root 3 by 2 minus 1 by 2 minus I root 3 by 2. We get is equal to 0. Sum of the roots of unity will be is equal to 0. And we see that omega cube will be is equal to 1. So from this we arrive at the conclusion that in general omega power n, nth roots of unity omega power n is equal to 1, and this sys2, or you can say that sys2 pi value will be is equal to 1. Sum of the roots 1 plus omega square up to nth root plus omega power n minus 1 will be is equal to 0, and the roots are in GP with common ratio omega. The roots are in GP with common ratio omega. Then we see that the arguments, that is the theta values, are in AP with common difference, which is equal to 2 pi by n, and the product of the roots will be is equal to minus 1 whole power n plus 1. Very important. Next question, JEE Main 2021. Root 3 plus I whole per 100 is equal to 2. Root 3 plus I can be written as R is 2 here. So cos of pi by 6 plus I sin pi by 6. Theta lies in the first quadrant. Now this is raising to the power of 100. The question is raising to the power of 100 here. We get this is equal to 2 power 100 into cos pi by 6 plus I sin pi by 6 whole power 100. Applying the Moivre's theorem, this is 2 per 100 into cos 100 into pi by 6 plus I sin 100 into pi by 6. Now this can be further written as 2 per 100 into cos 50 pi by 3 plus I sin 50 pi by 3. This is equal to 2 power 100, 50 pi by 3 can be written as, this is equal to minus 1 by 2 plus I root 3 by 2, which gives us this is equal to 2 power, taking 2 power minus 1 here becomes 100 minus 1, that is 2 power 99 into minus 1 plus I root 3. So from this we get P is equal to minus 1 and Q is equal to root 3. So sum of the roots will be P plus Q. Sum of the root will be is equal to P plus Q, which is equal to root 3 minus 1, and the product of the root will be is equal to minus root 3. Therefore, the given quadratic equation must be x square minus sum of the root into x plus product of the root. So our answer must be x squared minus root 3 minus 1 into x minus root 3. Minus 4, which lies in the third quadrant, minus 3 minus 4. Now this angle is 180 degree, which is being rotated in the anti-clockwise direction. If z is multiplied by minus by I, so we get 3i minus 4, or this is minus 4 plus 3i, minus 4 plus 3i. Minus 4 plus 3i lies in the second quadrant, and therefore if z lies in the first quadrant, then iz will lie in the second quadrant. Now joining this z and iz, we get a triangle. When I want to find the area of this triangle, This is Z and IZ given here. I want to find area of the triangle. Area of the triangle is half of modulus of Z and modulus of IZ, which is equal to half modulus of ZI into modulus of Z, which is equal to modulus of Z square divided by 2. So we have seen the definition for nth root of unity x bar n is equal to 1. Formula x power 1 by n can be written as is equal to cos 2k pi by n plus I sin 2k pi by n, where k takes the value 1, 2, 0, 1, 2, n minus 1. And the geometrical interpretation, the roots are the points lying in the unit circle in the Argand plane forming the vertices of an n-sided polygon. For cube root of unity, we say that the points lie on the unit circle forms a equilateral triangle. For the fourth roots of unity, the points lie, the roots are 1, I, minus 1 and minus I, and joining these points form a square. So, joining the nth roots of unity, it forms an n-sided polygon. The sum of nth root is 0 and the product is given by minus 1 whole power n plus 1. Distance between any two given points Z1 and Z2. Modulus of Z minus Z0 is equal to R, represents a perfect circle centered at Z0 and radius is R. Modulus of Z minus Z1 is equal to modulus of Z minus Z2 is a perpendicular bisector of the line segment containing the 2 points Z1 and Z2. If Z1 and Z2 are two complex numbers, then if the condition satisfies the distance between Z minus Z1 and Z minus Z2 are equal, then the perpendicular distance, that is a perpendicular bisector of the line segment joining Z1 and Z2. If Z1 and Z2 are any two complex numbers, then Z is equal to Z1 of Z2 divided by n plus m. The next one, if ABC represents the vertices of a triangle, then the centroid of the triangle is given by, centroid will be is equal to Z1 plus Z2 plus Z3 divided by 3. The orthocenter of a triangle is given by A secant A. Small a represents the side and a capital A represents the angle Z1 plus B. The incenter is given by, incenter of a triangle ABC is given by is equal to Z plus Z3 sin 2C whole divided by sin 2A plus sin 2B plus sin 2C. The result related with a triangle, a given triangle with the vertices Z1, Z2, Z3, we have the result for equilateral triangle Z1 square plus Z2 square plus Z3 square is equal to Z1, Z2 plus Z2, Z3 plus Z3, Z1. Or it can be given as, or this is 1 by Z1 minus Z2 plus 1 by Z2 minus Z3 plus 1 by Z3 minus Z1 is equal to 0. If the triangle is an isosceles triangle, then the area of the triangle can be given by 1 by 4 times of determinant of Z1, Z1 bar 1, Z2, Z2 bar 1 and Z3, Z3 bar 1. Next question. If S is equal to Z belonging to the set of complex numbers modulus of Z minus from Z to 0, minus 1, and this is the distance between the point Z to 1, 0. So when we plot the points here, this point to the circle, therefore n of S will be only a single point and that point will be is equal to 1. The number of elements in the set n of S will be is equal to 1. Equation of line. Equation of a straight line is given by A bar Z plus A Z bar plus B is equal to 0, where A is a complex constant and B is a real constant. How to identify it is the equation equal to A conjugate. Now this can be further simplified 6i into z bar minus z plus 5 into z bar plus z is equal to 5. Now z plus z bar we know is equal to 2x. Z plus z bar we know this is equal to the let z is equal to x plus iy. Z bar is equal to x minus iy. Now this is equal to plus iy plus yy goes off. This is equal to 2x, which is equal to 2 times of real of z. Now so this value is equal to 2x. Therefore z minus z bar, sum of the two numbers z minus z conjugate can be written as is equal to x plus iy minus x plus iy, which is equal to 2iy. So this will be 2iy. Now multiply 6i into 2iy plus 5 into 2x is equal to x. We know that I square is equal to minus 1. Therefore we get here this is equal to, this is z bar minus z, so this is minus 2iy. So we get here 12y plus 10x is equal to 5 will be the equation of the line. Note that the complex slope of the line a bar z plus a z bar plus b is equal to 0 is minus a by a bar. Compare this with the line equation ax plus by plus c is equal to 0. So slope will be is equal to minus b by a. So here it is minus of a divided by a bar. Next, two lines with complex slopes mu1 and mu2 are parallel or perpendicular if mu1 is equal to mu2, slopes are equal, and mu1 plus mu2 is equal to 0. The length of the perpendicular from a point A to the line is given by mod of a bar alpha plus a alpha bar plus b divided by modulus of a. Next, moving on to equation of the circle. Equation of the circle given with the center z0 and radius is equal to r is given by modulus of z minus z0 is equal to r. The general equation of the circle with the center as minus a and radius is equal to root of modulus of a square minus b is given by z bar plus a z bar plus a bar z plus b is equal to 0. The diameter of the circle, the diameter form of the circle, if z1, z2 are the endpoints of the diameter, then z minus z1 into z bar minus z2 plus z minus z2 into z bar minus z1 bar is equal to 0. Z bar minus z2 bar, or the argument or the equation can be given as argument of z minus z1 divided by z minus z2 is equal to plus or minus pi by 2. The equation represents a circle. The equation modulus of z minus z1 divided by z minus z2 is equal to k represents a circle if k is not equal to 1. It represents a circle, and if k is equal to 1, it represents a straight line. Next, moving on to standard loci. What is locus? The path traced by the point when it moves according to the some geometrical condition. The path traced by a moving point. So when the given equation modulus of z minus z1 plus modulus of z minus z2 is equal to 2k, where 2k represents a constant, this equation represents an ellipse. This is a shortcut ellipse if 2k value is greater than modulus of z1 minus z2. If it represents a line segment, if the difference between the two given points z1 and z2 are the two given points, if 2k is equal to modulus of z1 minus z2 and it has no solution if this 2k value is less than the difference between the modulus of the given 2 points, then this given 2 points, if the equation is of the form whole modulus of z minus z1 minus modulus of z minus z2 is equal to 2k. The equation represents an hyperbola if this 2k value is less than modulus of z1 minus z2, and it represents a line ray if this 2k value is equal to modulus of z1 minus z2, and it has no solution if this 2k value is greater than the difference of the modulus of z1 minus z2, and it depends upon the given equation from the question.